So I will show how to solve two equations in two unknowns the traditional way. So here we have two equations with two unknowns, x1 and x2. So what we do traditionally is that we take one equation and we isolate one of the unknowns, say x1, and then we substitute whatever result we get into the other equation. So let's try to do that. So I write the first equation here, and then my object here is to isolate x1. So first I subtract the 3x2 on both sides, and then I divide by 2, or I multiply by 1/2. So now I have an expression for x1. I can substitute this expression. Let me just frame it. And I substitute this expression into x1's place in this equation. So let's do that. Minus 3 times 1/2 1 minus 3x2 minus 4x2 equals -2. So what I've obtained right now is an equation that's only involving x2, and that's solvable. We know that. So let's just try to do this. This is minus 3 over 2 times 1 minus 3x2 minus 4x2 equals -2. So that's minus 3 over 2 plus 9/2 x2 minus 4x2 equals -2. So how many x2's have I got here? This is the same as minus 8/2 x2. So in total I would have 1/2 x2 over here, and then I add this 3 over 2 on each side, and I obtain -2 plus 3/2. So what we get is 1/2 x2 equals -1/2, and x2 is then -1. So now what I want to do is I want to take this result and substitute it back into this expression for x1. So let's try to do that. x1 is then 1/2 1 minus 3 times -1, which is 1 plus 3. So that's 4, and divided by 2, that's 2. So this would be the traditional way of solving two equations in two unknowns. However, this can be done in slightly a different way, and I'll show this in another video.